Okay, so part 2 of the lesson is let's look at some more examples for the derivative of ln x. So if we look at this one here, it's actually a product rule. We have 5x cubed and we have ln 10x squared. So I'm going to actually put those into two parts. So I want to say that a of x is the 5x cubed, and I want to say that b of x is ln 10x squared. Well, I can take the derivative of 5x cubed, and I'm going to say that a prime of x is 15x squared. Then I can take the derivative of b of x. Well, b prime of x, if we take the shortcut that we were using, then it says that I can do the derivative of this, which is 20x, all over a to the x function part, which is 10x squared. And I'm going to simplify this down to 2 over x. And now I can apply the product rule. So we say dy by dx is equal to a prime, which is 15x squared, times ln 10x squared, plus 5x cubed times 2 over x. Well, I'm going to simplify this a little more. So I got 15x squared, ln of 10x squared, and this is the part I want to simplify. So I end up with 10x squared. Now I can factor out a 5x squared, and then I'm going to put in brackets what's left. So from the first part, I'm left with 3 ln 10x squared, and from this I'm left with plus 2. Let's look at this one now, ln x over x squared. Well, I can say that a of x is ln x. I'm going to use the quotient rule. If you don't like it, please feel free to use the product rule. I'm equally as happy with you to use that. And bx is x squared. A prime of x is 1 over x. And b prime of x is 2x. So if we apply the quotient rule this time, don't forget we're going to subtract. So let's do dy by dx. So we have a prime b of x minus a of x b prime all over x squared to the power of 2. Well, I'm going to simplify this out a little bit. So let's simplify this first part. That leaves me with x minus ln x times 2x all over x to the power of 4. I'm going to factor out an x, so I'm left with 1 from the first term and minus 2 ln x from the second term all over x to the 4th. Well, I can reduce this, so x is gone and this goes to 3. So this leaves me with 1 minus 2 ln x all over x cubed. Okay, let's look at one more example and then we'll do an application question. So I have ln of x squared plus e to the x. We can actually just go back and use the shortcut for this. So dy by dx, it's not a product rule or a quotient rule. It says that it's the derivative of this. Well, the derivative of x squared is 2x, and the derivative of e to the x is e to the x. And it's all over x squared plus e to the x. Okay, if we want to try to determine the equation of the tangent to y equals ln x squared all over 3x at the point where x equals 1. Okay, so this is a quotient rule. I'm actually going to use quotient rule. So I have a of x equals ln of x squared. And I have b of x equal to 3x. So a prime of x is equal to 2x over x squared. Okay, this coming from the derivative of x squared is 2x all over x squared. And I can simplify that to 2 over x. And then the derivative of b is 3. So let's look at dy by dx. Well, that's a prime b of x. We're going to subtract ln x squared and 3. And this is all over 3x squared. So let's simplify this. This gives me just 6 minus ln x squared times 3 all over 9x squared. Well, I can factor out a 3. So I'm going to write 3, and I'm left with 2 minus ln x squared all over 9x squared. Well, the 3 and the 9 can reduce. And I'm left with 2 minus ln x squared all over 3x squared. So at x equals 1, the slope is equal to 2 minus ln 1 squared all over 3 times 1 squared. If you check on your calculator, ln of 1 equals 0. So this gives me 2 minus 0 over 3, or 2/3. I need the point at x equals 1, so I'm going to plug in 1 into the original function. Well, if ln of 1 is 0, this just gives me 0. So this gives me the point 1, 0. So if I plug these in, I get to the equation of a line. I'm going to get y minus 0, 2/3 x minus 1, or y equals 2/3 x minus 2/3. If I want to change this into the Cartesian or general form, I'm going to multiply everything by 3. So I'm going to take y equals 2/3 x minus 2/3. And I'm going to multiply everything by 3. Gives me 3y equals 2x minus 2, or 0 equals 2x minus 3y minus 2. And we're finished. Ta-da!